And we're back, everyone.
In black, even.
That was your line, right?
Yeah. Check.
Okay, so up next we have Adrian. And Adrian is the technical director of EA Romania. Hi, Adrian.
Hi, guys.
And I have to say, do you get a lot of developers that envy you? Because, for instance, I do. Because the first one we all, let's say, not got into this industry, but when we first had a computer, we used it for games. Again, maybe it's just me. But then yeah, I always wanted to, I don't know, build a game myself, or be part of the team that builds a game. But somehow ended up doing, implementing financial protocols or healthcare projects. So
Living the life.
So I think I missed that boat. But yeah, it's for me at least, it's going to be a very cool session to have a glimpse of how things go in the gaming world and what sort of technologies you do, and like you said in your session, how are you doing testing? How are you approaching this open world testing thing?
Absolutely. I hope the presentation will bring some light on how we do it.
I also hope I have small questions. I'm not sure if people ask you this a lot, but could you hook me up with a Ferrari in the latest NFS and the Heat? I mean, I can give you my account now, or should I just text you?
No, you have to do the proper. I mean, just getting a car to somebody. First, it's not possible. Second,
But if it were?
To be honest, I wouldn't recommend such thing because it will break the entire feeling. Because we have a lot of people, talented people who are working on the game, making sure that we bring the best experience to the game. Just having a really powerful car from the beginning will just destroy the initial experience and everything like that. So it's not something that I would suggest or have people do that, to be honest.
Plus, Vlad, you have to do the work like all of us.
I'm sorry you feel like this.
Play the game.
It's like having a lot of money in your 20s. Who wants that? It ruins the whole experience.
All right, Adrian, well, you have the floor. I can just share your screen, and then we'll see each other for questions afterwards.
All right. I hope everybody can see my screen properly.
Yeah. You also stopped your camera. Not sure if it was intended or not.
Yes. Do you want me to keep it?
Yeah, you can keep it. It's up to you. It's up to you.
It's fine. Okay. So let's start then. Hi guys, thank you for joining this presentation. In the next 35 minutes, around 35 minutes, I will talk about the Need for Speed development, especially on the cloud scalability within the Need for Speed Heat as a AAA open world game. Also, I would like to mention that the best questions who will be asked at the end of the presentation can receive some swags from EA containing EA counts for the games we are developing. So keep an eye to the presentation and let's see those beautiful questions at the end. I hope I can also answer them, but let's see. All right, let's start. First, let's look a bit at the agenda. I will present initially some Need for Speed facts. What does it mean to be an open world game? Then we will talk about the testing numbers. I will explain how the automation and the amount of test and the type of test we did in detail. I'll mention what test framework is, then how we move to cloud, and at the end some key takeaways together with the questions. Need for Speed Heat as an open world. What does it mean? First of all, we have only one level. That means when you enter that, you have a world. We call it the world. In Heat, the size of the world is around 10 kilometers in square. In that world, we have more than 523 kilometers as part of the road network roads, not mentioning the off-road that we also have. When it comes to events, what is an event? We call it an event in Need for Speed. An event is a race that you can do as part of the missions of, and also as part of you playing with your friends or with an AI doing missions through the entire world. So when it comes to events in Payback, the previous title we shipped, we had around 148 events. While in Hit, the last title we launched, we almost doubled the amount of events, reaching up to 286. This not without mentioning the additional events we added as part of the live service program we had in both Payback and Hit. Regarding cars, our game has more than 120 cars. You have the ability to play either online or offline. If you choose to play online, you will have 16 clients connecting to a dedicated server and being into that world together with the other 15 players. You can start doing various events together with them or just play as you wish. Also, in Need for Speed Hit, we added another functionality as part of our core loop. We added the option for the players to play the game during day or to play the game during the night, which has a different experience for each case. Now let's look a bit at the numbers. Speaking with the quality verification team, we realized that while developing Payback, we had more than 24,000 issues. While developing Hit, we had more than 19,000 issues, bugs, meaning bugs. Looking at the hours spent by testing these two last two games on Need for Speed, the QV teams spent around 145,000 hours testing Payback and around 136,000 hours testing Hit. Now, just looking at these numbers, it means a lot. Of course, they are part of the 2-year cycle of development. However, the numbers are still a lot. And looking into the future, we realize that the games will grow, not just Need for Speed. All the AAA games will grow in both size and also the complexity. So that means we won't be able to sustain this amount of testing just using humans or persons as part of the QV teams. So what could we improve? We thought about that. And the answer was obviously, how about we move as much as possible into the automation, creating test and test strategy which allow us to provide a better quality of the game we are developing. As part of the automation, we wanted to test as often as possible. We wanted to test more than the previous title we had. We wanted, being part of the automation, to test all the time if possible. We wanted to have fast tests, which will provide short validation of the basic functionality, but we also wanted to have longer tests, which will take more than a few minutes to test a bigger functionality of the game. Also, having this test, we realized that it's not a good practice to develop the features and at the end to start developing the test for them. We needed to embrace and bring the test as part of the development. So that means once you develop a feature, a part of the capacity, the time spent developing that feature, you need to take in account developing a test for that. The reason is pretty simple. Once you have an engineering team which develops a feature in a game, in Need for Speed, once the feature is complete, you will move into focusing into another feature. You have, while doing so, you have to leave something, in this case an auto test, which proves that the feature that you're not focusing mainly on it anymore still works, considering all the changes that you will bring in the game as part of the development cycle. So therefore, you need to create an auto test for every feature. Also, having all these features as part of the automation, you need to hook them up into something that we have, and it's called biometrics, which is actually the bug database we have. So all the tests who are running on the automation to properly report into our bug database and helping the QV team on their tests. Now let's go more in details when it comes to automation. First of all the tests we had for Need for Speed and we developed for Need for Speed Heat, we developed them to run on all the platforms we shipped Need for Speed Heat on. So that means we had 3 scenarios on PC, low spec, medium spec, and high-end specs. We had tests running on all the Xbox family we launched, meaning Xbox One, Xbox One X, and Xbox S. And the similar for the Sony PS family, PS4 and PS4 Pro. Now for all these tests, we started with smoke test. We call them also the tier 1. Smoke test means that you have around 20, we have around 20 small tests that you run in a sequence in the same testing session, having a total of 5 minutes, where you want to test the basic functionality of the game, ensuring that every change that you bring in the game, every submit that you do in your development branches are safe enough and they're not blocking other teams or other development teams, or they're not blocking the QV teams. As part of this smoke test, for example, we test that you can boot the game. Once you boot the game, you can enter properly the world. Once you enter the world, you can spawn the car. Once you spawn the car, you can spawn items on that car as part of the customization features that we have. Once you spawn the car, you test that the AI can drive the car to a certain point. Then you test that you can spawn a police car. Next, you test, once you have the police car in the world, you test that the police car can bust you if you have a certain hit level, like we had in Need for Speed Heat as a functionality. Then we test that the proper flow takes you into garage once you get busted. Then you test that you can go back into the world either by day or by night, and many, many other things. So we were running, and we are running this type of test for as often as possible for every change list or every set of change lists that are submitted into the development branches by the development team, by the engineers. A different type of test as part of the tier 2, and we call it the nightly, we wanted to test something different, meaning that every night we take the last stable build from that development stream, and we run a test having a coverage like between 1 and 2 hours. What we test here, we run 2 tests on it. The first test, we call it the wanderer test, which means that you spawn a car in the world, then the AI takes the car and drives this, trying to cover the entire road network that we have in the world, making sure that the car is not getting stuck in some places, it's not falling through the wall, creating, I don't know, a crash or maybe a disconnect from the server. And we wanted to make sure that every night we have the road network working as intended, and you can have the road properly set in the world. The second type of test we run nightly was to test the events themselves. So that means we launched a test where you spawn again the car in the world, and we provide to that test a list of events. That means the car teleports to in the world to the point where the first event in the list is, starts the event, finishes. Once it finishes, teleports to the second point where the second event is, does that event, finishes, and then the next one and the next one, so on. This allowing us to understand first that all the events are properly working, meaning that you can start it, you can have AI car spawning around you, you can finish the event, you can properly report things like experience, coins, and reputation that you can gain. And also we managed to, by doing this nightly, we managed to create for both the wanderer and the second test, we create something that we called a heat map. So that means we create two graphs that has the world with the road network on it, and we display the points and the routes where the car drove, allowing us in the first test to understand and see if we manage to cover the entire road network. If not, we know the places where it stopped and we can look and see what happened there. Maybe it stopped, maybe fell through the world, who knows, but you can see that. And also in the second type of test, you can understand based from the logs, but also from the heat map report you generate at the end of the test, if you manage to complete all the events that were on the list. During the weekends, we increased the nightly. We take the tier 2 nightly test and we increased it to 3-4 hours and tested running the same test but for a longer time. Also, while doing the smokes, the nightly and the test that we are running during the weekends, we are measuring things like frame rate. We are measuring things like memory allocation to make sure that we are within budgets or everything is working from stability point of view, meaning it doesn't crash, it works as intended. Besides this type of test, we created another performance test. That means we wanted to see how the frame rate is on specific points in the world. So we created a test which we ran it first as in the first setup during the day instance, and the second time during a night instance, where we teleport the car. Once we get the car in the world, we teleport the car to those specific points. Once it teleports to the first point, we spawn additional 15 cars around that the car, fully equipped. We wait everything to be spawned and loaded properly. We measure the frame rate, then we jump to the next point, and then to the third point, and so on until we finish the test. Once this test is finished for both night and day, for all the platforms, like I mentioned, on PS4, Xbox One, and PC, we create something, we create a heat map, again, like in the nightly test. We show on the world the points where the car spawned and where the tests, the measurements were taken, and also the values that we took, allowing us to identify if there are any points in the world where the frame rate, the performance is lower than what we were expecting. So that was the performance. Also, considering that Need for Speed Heat has the multiplayer component as well, as part of the smoke tests, like the initial one I mentioned with 20 tests and 5 minutes as a schedule, we created a multiplayer test to make sure that while we are developing and while we are submitting and changing things in the development streams, we need to make sure that the core components from the online, from the multiplayer perspective, still work exactly like in smokes. So that means we created a test where we get two clients. They are connecting to the dedicated server. Once they connect to that dedicated server, the server disconnects both of the clients. So in order for us to see if the clients behave gracefully when they are disconnected from the server. Once they got disconnected, they reconnect back to the server and they disconnect themselves from the server in order to see if the game server behaves gracefully when one or multiple clients are disconnected from the game server. And at the end, the third time we connect the clients back into the game server, and we put those two clients to do a small event together. Once this is finished, we can validate that at least the disconnects, the matchmaking, the loading of the game server, and the behavior of starting an event as a multiplayer component works. And this test, the multiplayer test, takes like, I don't know, 3-4 minutes. So it's something very fast, but useful for us to identify really early if there are some breakages on that part. So we are covering as part of the test, we are covering the performance in terms of stability. We are monitoring the memory usage. We are covering the events as part of the functionality, if everything works as we wanted. But we also wanted to understand another component of the game, meaning the car performance. With all the changes that we are doing in the game, developing features, we wanted to understand if this will impact or not the car performance, meaning will the cars still perform as intended. So we created a test which takes like 10 hours where we spawn a car in a circuit race, and for 10 hours the AI does laps on that circuit race. While doing these laps, we are monitoring the top speed of the car, how the braking, how the car brakes, handling when taking corners, and many other metrics, which allows us to understand that every change that we do is not gonna affect the car, and the cars are still working as planned or as created initially. We created this part of test, stability, monitoring metrics, performance on the car, but this wasn't something. We realized that we still wanted to test something that matches more closely to what the players will have when they are playing our game, meaning how the game and how the client, and both the client and the server, are going to behave when you have 16 clients connecting to a dedicated server and they start doing random events, some of them idling in the world, some of them sitting in garage doing some customization. So we wanted to try to match, at least in our automation farm, a behavior like this. Therefore, we created a soak test that takes 75 minutes. During this soak test, we get 16 clients connecting to the dedicated server. Once they manage to connect to the server, they will choose a random point in the world, drive individually taken by AI to that point in the world, start an event that is found on that, finishes the event, then choose a random point, doesn't matter where it is, a random point in the world, drives to that point, starts an event, and does that for 75 minutes. So we have 16 cars driving randomly and doing events randomly for 75 minutes. While doing this, we also taking every minute a screenshot for every client, a client meaning a PC or an Xbox or an PS. We take screenshot. On those screenshots, we display the location in the world where the car is, the frame rate, the memory metrics. And once the test is finished, we display, as part of the reporting, a web page where we display all the screenshots with the cars that were taken from the clients and from the cars. Just looking at those screenshots, sometimes we found issues like I mentioned earlier, with some cars, I don't know, sitting in infinite loading, other cars not advancing and just sitting in the middle of the street, or some cars getting stuck into, I don't know, a warehouse, some buildings in the city, or even in some forest. Just having those screenshots and looking at them, and having the world coordinates allowed us to identify the location of some potential problems. Speaking with the world engineers, we identified in some cases, for example, invisible objects who had collision, not allowing the car to advance through the world. Also, making sure that the splines and the routes for the road network are properly set. So we had this soak test with 16 clients doing random events covering the world, and we run it every 2 hours during the development days. So that means on a normal day, we managed to cover like 3, 4, maybe sometimes 5 testing sessions. Pretty much we take the last build and we run the soak on it. So this is a part, or a list of the variety of the tests that we had and we created as part of developing Need for Speed Heat. And we managed to launch most of these tests on more than 8 development streams we had in parallel as a peak while in developing. Just looking at this amount of tests, just looking at the frequency of some tests, we realized that we need to increase and change the hardware infrastructure. So we increased the automation farm, adding more consoles and PC into that, but also this wasn't enough. We also needed to change the architecture. Architecture meaning how fast can you deploy the builds that the automation is building, how fast can you deploy them on console, then launch the tests, how fast then the console can recover once the game crashed, or how fast can you report the results of the test once the tests are finished. So we had to improve the architecture on that part, the tech part on that as well. Now, having all these tests and increasing the amount of tests that we did, we also realized that we need to work on how we are going to report the results of these tests, because just trying to look at the console and getting the logs and the screenshots was not easy for any person to do. Therefore, we needed to find a way to report so it would be easy for everybody. Just look at the dynamic reporting, how we call it, and say, yes, we are in a good position on that stream, or the project is stable from the stability perspective and tech KPIs. So we created a web page. Just looking at that web page was enough for you to understand how the builds are behaving. Now, on every stream that we had the test running on, we displayed for every change list that was submitted into the development stream, we displayed all the tests that we were running, the results of the test, and just by some clicks you were able to get all the proper information. Just to give you a small amount how it looks, this is really a small part from the entire dynamic reporting tech we had. What you can see here is the tier 1 smoke test, like I mentioned earlier. Some of them, the green ones, finishing successfully, some of them failing. As you can see, we run it on PS4 normal, which is the normal PS4, PS4P, which means PS4 Pro, so for Xbox One and Xbox One X. And also you can find here the standard multiplayer test suite, like I mentioned, just testing the basic multiplayer functionality for the game. Just looking at this, you can understand that in that change list, you had some problem with a specific test. Just clicking on one of them will provide you the error messages, a short call stack, and also a link to the Jenkins, which will provide you the whole information you need to understand what happened with that test. Meaning, the entire TTIs, the console logs, the crash dumps, if any, and also the screenshots to have a better understanding what happened on that part. So this was part of the dynamic reporting. Now, with us creating all this type of tests and understanding that in the long run we need to create more tests and to test them longer, we knew that we need to find a unified way to manage all these tests. So we came with the idea to create a test framework that the main purpose and the entire purpose of the automation part was to cover the deterministic part of the game. What does this mean? It means that everything that you can test in a repeated way, the same event over and over and over again, covering, making sure that the road network is working as intended, that the splines are set properly. These things you can do through the automation. So this is what we wanted to achieve with the test we developed and also with the test framework, and leave the non-deterministic part to be tested by our QV teams. Of course, the second target was to make sure that we cover everything when it comes to functionality in the game, to cover the entire world and cover all the events that we wanted to have and we had in the game. Obviously, it had to be easy to add additional tests. We started to hook in the test frame the previous tester that I was mentioning, to be driven by the dev team, because this test framework was still in development and we wanted to improve even further. And the most important, we wanted to for the test framework to match as much as possible the player behavior, meaning that we wanted to create tests that instead of being just on one console or one client, to be on 16 clients connecting to a dedicated server. So that will map better the things that our players will experience. Also, as part of the test framework, we wanted to create some testing scenarios. A testing scenario means that when you have 16 clients connected on a server, you can specify scenarios for that will be run for every client. If you, for example, if somebody from the QV teams comes and say, we found a problem on a certain event, but we weren't able to reproduce it anymore, you could take that and put it into an automation test and set, I don't know, 10, maybe 12, even see all 16 clients to do that event over and over again, finding the issue, or at least increasing the chance to reproduce it. So we could cover, by having testing scenarios, we could cover the randomness part of the testing, let the clients choose their own points and drive through the world how they wish. But also we could specify to some clients some tests to run into a specific order, or to run a specific type of event, or even a specific event. So we had this as part of the test framework, but all of this was done into and for the automation farm we had. And as you saw, and as we understood it as well, that will be limited also, because you cannot increase endlessly the amount of hardware. So definitely we wanted to move into cloud. As part of the cloud testing, we already had some parts of the cloud testing since we launched Payback. And that was for game server, testing the game server. Both Payback and the last title, Need for Speed Heat, we launched, have their game servers deployed in cloud. Instead of having some hardware in our farms, we turn to cloud. So that means in a VM, while launching in a VM, we can have more servers in the same virtual machine in cloud, and have the physical clients, the players, connect to those servers and being able to do all the events and play our game. As part of having the test for the stability of our game servers in cloud, well, we were testing matchmaking and disconnects by scripting. That means we wanted to understand how the game servers are behaving when you have, I don't know, thousands of players matchmaking into your server. So we created scripts which allowed this, and got virtual clients connected into our game servers, and the same for the disconnects. While doing this, we also did what we call the load test. We also wanted to understand how our game servers will behave when you put under pressure the VM itself. How the game servers will behave when you increase, for the example, the CPU usage on that VM, or you lower the bandwidth, or you lower the memory available on that VM. Will your servers or game servers still hold? Will they perform as intended or not? So we had this as part of the cloud testing for the game servers. What we were missing, however, was the part where we wanted to understand how the game server behave when you were facing players, meaning instead of just having scripts connecting and disconnecting to the game server, how about we see how what happens to our game servers on a large scale in cloud when you have players, scripted players in our case, Autotest, doing various events, going through randomly through the world, and everything like this as part of the test. So we looked into moving also the Autotest we were having on our automation farm. We looked into move them into cloud as well. So what we wanted to achieve, we wanted to take the SOAP test that was launched by the test framework. SOAP test is the test that I explained a little bit earlier. When you have 16 clients connecting to a dedicated server, and they start driving to certain points in the world and start events that are found on that point, and then take on the next event, and so on, so on. So we wanted to have this because that would map at least better the player behavior. And we wanted to move the client builds into containers in AWS. And also to reduce costs, we wanted to have multiple clients in the same VM. So this is just the clients, not the game server. But when we try to do that, we realize that we have a problem. The problem was that our PC builds, because it was in this case just PC builds, it's kind of impossible to test console builds on cloud. So once we start deploying in VMs the PC builds, we realized that our builds required, and there was a requirement from the VM setup to have a high or really powerful GPU, because we have a rich world, the cars are really detailed. So therefore we needed to launch our clients in VMs in cloud with a high GPU setup in order for the clients to perform at a good frame rate. And that was a problem for us, because it would have been increasing our costs when it comes to every testing session on a large scale. So we looked into that, and together with the Frostbite team, we developed something that we call the team client. A team client means that you're able to take the PC build and run it in the same logic. Everything happens exactly the same. You still have the same setup, state transition, collision, physics running, matchmaking, all the things within the game. You have it running properly, but you don't need the GPU at all, because you're just not rendering anything, except that you keep the functionality of the game as intended. Having this technology allowed us to start booting clients, team clients into VMs, having multiple clients per same VM, and start testing our game and matching the player behavior, like I mentioned. Once we did this, we reached a point where we had up to 9 hours as a testing session, with more than 20 servers being up in the cloud, and having the 320 corresponding clients or even more still also in cloud, connecting to the dedicated server with our test framework and soak test running, and understanding what's starting the race, doing events all across the world. While we did this, we start also, of course, to measure and monitor performance on both client and the game servers to understand now in this new situation how they are behaving. Also, having all these tests on a large scale connecting to our biometrics database started to pile up some issues that initially were found more rarely or in low occurrences. Having right now in cloud testing on a larger scale allowed us to see the top, we call them the top offending issue, because we realized that a game of this size is pretty much impossible to fix all the bugs that we will have in the game. How about being smart and fix the most important one, then the next one, and so on. Having the automation in cloud testing allowed us to identify those. And once we start fixing the top offending issues, we started seeing the stability and the performance improving. Then we fixed the next ones and the next ones until we reached to a point, and even further continue fixing, but we reached a point where we met the EA standards in quality and stability to ship a game at launch. For example, once we start doing the cloud testing session, we used Datadog to gather the metrics that we had from the game. This is just a small part of the metrics we are measuring. So, but I use this to explain better some situation. As you can see, this was a session that had around 16 game servers up with the corresponding players connecting. As you can see, the number of servers in the middle top graph, and the corresponding players connecting in the top left corner. And during this session, which was around between 7 and 9 hours, we had 4 server crashes, as you can see in the bottom left screen. Of course, during the development, we had multiple or more crashes. This is just an example. So we had 4 crashes. The server frame rate was stable around 30 FPS. And the last metric on the bottom is an internal metric which allowed us to understand that the clients are actually doing events beneath and while running the auto test. But we could get to that information from logs as well, but this was easier to have. So we had 4 crashes. Having this displayed allowed us to get the logs and the TTIs from the logs from the server and from the clients, the crash dump from the server. We start fixing them, solving those issues, and then we run another session and so on until we reach a point like this. This is something, a test that was really was successful, somewhere close to our launching phase, where you can see we had the similar amount of time as a testing session with between around 9 hours, I would say, with 0 server crashes, as you can see in the bottom left. The frame rate for servers stable as well at 30, and no clients getting disconnected, as you can see in the flat line on the top left graph. And also running as intended in terms of our game modes, events on the bottom right corner. Now, as a takeaway and key recap, I would like to mention that as part of the testing, we wanted to, the main goal for us was to create a system that was able to take as much as possible the deterministic part and move it to automation, then move it to cloud, and allowing us to process more data and making sure that we find most issues and the top offending ones in order to increase the quality of the game and provide to our players a great experience. Also, to be able to expand more as a testing scenarios in cloud, and not to mention having this amount of data provided to you, you need to improve and continuously improving the way you report that data by aggregating data, by using Datadog or maybe other things like Grafana to display, to have a better understanding what's happening with your project as part of the development and also as part of later on when you launch the game and you have millions of players enjoying your game. Thank you.
Thank you, Adrian. Really insightful. Yeah, maybe we can expand about a bit about so NFS is yeah, what's called the AAA game. So that means large budget, but implicitly also a large team. How does a team for such a game looks like? How many people? How do they work together? What sort of skills?
In terms of as a skill set or numbers, in terms of numbers, we're looking at more than 100 people working as a core team. And as a core team means engineers, designers, producers, even people from also dev QA who are helping us during the development cycle to test. And this is just the core team. Besides that, there are so many other teams who are part of the development of a AAA game. For example, you have the legal team who needs to make sure that all the cars, because all the cars in Need for Speed are licensed, you need to make sure that you met the requirements from the legal agreement you have with that, not to mention the rights with the assets you use, commercials, what else, songs that you use in the game, everything is, so you have a legal team. You also have the art team, which they are the ones creating these beautiful landscapes and textures for the world we have, and also they are creating the cars for us. Just to mention 2 of them, because there are more. There comes the, once you're close to launching the game, you have other teams who are helping us. In our case, for example, we had a team which is located in India that was helping us with deploying the builds in cloud and running the tests in cloud. They were in charge of spinning the VMs shutting them down, providing the metrics, making sure that Datadog is running as intended as part of the containers, running, creating the scripts. We have security teams who are testing our game to make sure that there are not any breakages. We have certification teams that verify that you have you meet all the requirements from the first party, meaning from Sony, Microsoft, and Origin when you're ready to deploy a game like this. So it's not just 100 per as a size number. There are so many people and so many across the world within EA who are helping and working on developing a beautiful game like this.
Yeah, it seems to be a large effort involved. All right.
We also have a few questions from the audience.
Yeah, quite a few. Let me check the first one. I think you briefly touched on that before, but let's see if there's something to add. So for the automation test, did you use any framework or it was developed in-house? I think
it was developed in-house.
And if you did it in-house, did you develop it to use it also in the future, or it's specifically for this project?
We started specifically for this project because there are different technologies that we used, but also we were looking into maybe creating a unified test framework we wanted to have. We wanted to reach a point where it was stable enough and provided good coverage for our game, then to reach to other studios and have a chat with them and see if we can use that together, and them using our technology or the other way around. And also I mentioned when we extended the hardware, I mentioned that we needed to change the architecture for the hardware in terms of how fast can we deploy that the builds into the consoles, and how fast can we shut them down and recover them from crashes. This part was developed as an unified central technology that every team within EA could benefit if they want to. So it wasn't some parts were developed in-house, like Autotest, because it was depending on the feature set we have in the game, but the frameworks like the one I mentioned was developed as part of a larger initiative across multiple studios within EA.
All right, this is something that I had in the back of my head. How much, for instance, do you reuse from one game to another, and from the same family, of course?
Well, depends. First, you can look into the assets. Assets means textures, means cars, means objects you have in the world. You can reuse those if you plan to have the game into a similar scenario. But if you plan to change completely the game, then definitely you need to look into changing those assets as well. When it comes to technology, yes, we're looking into, every time when we are looking into developing something, definitely we're not looking into develop something that will solve just the current problem. We're looking into expanding and trying to understand the future usage of the user, or the usage of that tech we are developing in the future.
All right, moving on. I think I had one.
Yeah, I'm curious. There's a question. I'm really curious if you're doing this. Do you also test the performance of games in cloud streaming services? For example, like Geforce Now or Google Stadia?
No, not yet.
All right.
But that doesn't mean that we're not gonna look into that.
Well, at the moment, it's pretty cloud streaming. I think it's pretty in its infancy. So yeah, in a couple of years, maybe it will be more advanced. There's another interesting one. You mentioned that you didn't render anything in the cloud. So this means
In the cloud, yes.
You're not checking the textures and the models in the cloud.
Yes, we do. You load them, you assign them, but you're not rendering them. So the only thing,
right.
Imagine that you're running everything, but you're rendering everything into a black screen. because you want to see the performance and the same behavior. Sometimes for a car, for example, in order to have the proper physics, the physics is it's tied into the volumes and the geometric shape of the car. So definitely you need to load those and have them when you have collision with another car. So we did this except the rendering part to reduce the GPU, and of course the shaders that were required for the GPU, obviously.
Well, it makes, yeah, game development is an interesting beast.
I think let's do one more. We also used, or how much unit testing have you used? Because it seems like a lot of the effort was on integration testing.
Yes, we had also the unit testing, and we wanted to increase that as well, to add as much as possible of the unit tests. But this was more focused into what can we move away from the QV team to help them test more things, while we do as part of the automation, we do the repetitive tests, the deterministic part, as I mentioned. But definitely we had, and we are running unit tests as well. I just didn't mention them.
All right, makes sense. Vlad, do you have another question?
There is one other question, but basically it asks if you've tested the test framework. Basically, how do you make sure that your test framework actually indicates issues with the game and not with the test framework? But I'm assuming you've checked.
Yes.
The answer is by checking.
The test framework was created so it can just imagine that the test framework was pretty much as a test launcher. That was pretty much everything, to have something that manages the tests. So you allow the engineers to create their own tests, but the only thing that we need to check is that the test they are developing can be launched from the test framework. And then it's up to us to create scenarios when we wanted to extend and launch from the test framework, while, like I mentioned, having 16 clients on a dedicated server, you can set one client to do pretty much nothing, just sitting idle, or just entering garage and world and back and forth. You create a test on that and you hook it to a scenario for that client, while you add other type of scenarios for the rest of the clients. So it was just as a part of the launcher.
All right, so yeah, basically you make sure that the individual tests make sense and they can be run.
Yes, because it was part of every test to be able to be launched individually without launching from a test framework. And we also wanted that whoever does the test make sure that the test is running as intended. It's on them to make sure that the test is valid, and also it has a proper recovery once test itself fails. The test manager just needed to know, I'm done, give me the next test from the test framework or from the scenario, and the client just start doing that.
I think it's also similar to regular unit testing. I mean, when you write a unit test, how do you make sure that when the test fails, it's an issue with the program and not with the test framework? On the one hand, you make sure that you're using the right test framework, and then also you write and assert false in the beginning. All right, I think we've run out of time, but thank you for this very, very insightful talk. Dan, I'm not sure we should start our own game development company just yet.
No, like I said, it's too late. Probably it's too late for us now. But it was, it was good to have an insight on what we missed, right? All right. Thank you, Adrian. It's been great having you here.